You copied your public key to a server, ran SSH, and still got a password prompt. Same laptop, same private key, no obvious error. Or worse, it worked yesterday, then someone cleaned up permissions, and key login stopped. That failure usually lives in one place: the server-side authorized keys file, or the path leading to it. Today we are not just fixing one login, we are learning the exact decision SSHD makes when it accepts, ignores, or rejects your public key. The file named authorized keys is a per-user allow list. If you log in as deploy, SSHD checks deploy's home directory, usually deploy's .ssh directory, and then the authorized keys file inside it. Each line is one public key that is allowed to authenticate as that account. Your private key stays on the client. Never paste a private key into authorized keys. The normal line has a key type, the long public key blob, and often a comment, such as a laptop name or owner. One public key per line matters because SSHD parses the file line by line. Break the line, wrap it in email, or paste two keys together, and that entry is no longer the key you think it is. Here is the flow. Your SSH client offers a public key identity. The server checks whether public key authentication is allowed, then looks at the account you are trying to become. By default, OpenSSH reads the path configured by the authorized keys file directive, commonly .ssh/authorizedkeys. If it finds a matching public key line, that is still not enough. The server sends a challenge, and your client must prove it has the matching private key by creating a valid signature. That means possession of the private key is verified without sending the private key over the network. Then StrictModes, enabled by default on normal OpenSSH servers, checks ownership and permissions so another user cannot sneak keys into your account. The safest everyday installer is ssh-copy-id. The first command uses your public key file, id_ed25519.pub, and installs it for user on host. It logs in using your current allowed method, often a password the first time, creates the remote.ssh directory if needed, and appends the public key without you manually copying a long line. The next command tests the result with a normal SSH login. The chmod lines are run on the server, inside that user account. 700 on .ssh means only the user can enter or modify that directory. 600 on authorized keys means only the user can read and write the allow list. Some systems accept less restrictive read permissions, but this baseline avoids surprises. Say you have a new VM and a local laptop key already created. The VM account is VM admin. From the laptop, run ssh-copy-id with the public key path and VM admin at the VM name or address. You enter the account password once. On the server, ssh-copy-id ensures VM admin has a .ssh directory and appends exactly one public key line to VM admin's authorized keys. Now open a new terminal and SSH to the same account. If the client offers the matching private key, the server finds the public key line and asks for proof. The private key signs the challenge locally, SHD verifies it, and the shell opens without a password prompt. Most authorized keys failures are boring, which is good news. A copied public key got line wrapped. The file is owned by root instead of the user. The user's home.ssh directory or authorized keys file is writable by a group or by everyone. With StrictModes, SSHD may refuse to use the file, while the client only shows a generic authentication failure or falls back to password. The useful detail is usually in server logs, such as auth.log or the journal for SSHD. Security-wise, remember that authorized keys is access. If an employee leaves, the laptop is replaced, or an automation key is retired, remove that public key line. Deleting the line revokes that key's access for that account. Authorized_keys sits between client identity and server policy. The client key pair answers the question, what private key can this user prove they hold? The authorized keys file answers, which public keys are allowed for this server account. The SSHD config file answers broader policy questions, whether public key authentication is enabled, where authorized key files live, whether passwords are allowed, and what restrictions apply. Later in the series we will cover SSH agent, passphrases, certificates, forced commands, and detection. This episode is the foundation for all of those. If you do not understand this file, every advanced SSH topic feels like magic. It is not magic. It is a controlled allow list. Use a machine or VM you administer. Create a lab key with the command on screen. Use a passphrase if this is not disposable. Install that public key to your test account with ssh-copy-id. Then log in using that identity file, or let your client find it if your configuration does that. On the server, inspect .ssh/authorized-keys and find the new line. Confirm it is one full line. Run chmod 700 on .ssh and chmod 600 on authorized keys. If you want to see the failure mode, in a lab only, make the directory group writable, try login, then restore the permissions and check the server log message. 3 beats to keep. First, authorized keys is a per account allow list, and each public key belongs on one complete line. Second, ssh-copy-id is the normal safe way to install your public key, because it creates the right remote structure and appends instead of making you paste by hand. Third, permissions and ownership are part of the security decision. Use 700 on .ssh and 600 on authorized keys as your baseline. Remove old public key lines when access should end. This is SSH Mastery, 1 SSH topic per day, from 0 to expert. Also check the daily ranked CVE brief for what defenders should patch and watch next.